particular video, we are going to present the animation of points using the plot to the graphics. And for that purpose, we're going to start by looking into this particular worksheet. What I mean by animation of point is creating positions where the point is changing as time changes, and in this case, time is represented by the angle theta. So I have created a range of values of theta between minus pi and pi with increments of pi over 2. And I'm going to make those, the particular point that I'm going to use is going to move around in a circular radius equal to 5. This function f of theta generates the x and y coordinates of a point, and then it shows the point as a dot, but with a relatively large size of 40 and color blue. By doing the animation here, clicking in there, then right click, animate, we have the angle theta as the time animation, and so that produces this point that is changing position as theta changes. Now if I do a click first and then right click, I could change the frame rate, like this one is going a little bit fast. I'm going to put it at 5, and so you can see the point now going slowly in that particular path. The path of that animation is a circle. So what I did, I created this vector, it's a vector called path. Center is 0, 0, is an O, which is basically translated into a circle. And then I start playing with the radius of that circle, the size of the symbol in red color until I got a circle here that corresponds to the path of the point that I animated earlier using this function. Now, to make things a little bit more complicated, instead of having a single vector, I produce this matrix with 2 rows where the first point is the regular xy function of theta, but now I change the angle to minus theta, and it produces a reflection about the x-axis of the point. For example, you can see the green point going around, but at the same time the blue point going reflecting about the x-axis. If instead of changing the angle to minus theta, I change the minus sign outside of the coordinates corresponding to these two, I get these 2 points reflecting about the origin and moving around in the circle. I can make it even more complicated by adding 2 more points. The first point is just my regular xy. The second point is the negative, that means the reflection about the origin. And then I also take this and add a phase of pi over 2. That produces a point that's 90 degrees off the first one, the green one. And then if I change the sign of the coordinates, I get a reflection about the origin. And so I end up with 4 points rotating, separated by 90 degrees. I can make it even more complicated by adding angle phases of pi over 2, pi over 4, 5 pi over 4, 3 pi over 4, 7 pi over 4, and I get 8 points rotating in the circle. I'm going to go back to a simpler case where I'm going to generate my xy coordinates using these formulas, and then I'm going to create a vector here, or a matrix actually, that will show the points x, y, and minus x minus y. The first one is the blue circle, the second one is the green circle, and I also provide a matrix with the coordinates of x, y, minus x minus y, which basically creates the bar, the little connection between the 2 points. And so the figure here looks like a bar connecting the 2 points, rotating about the origin. And then I try to generalize my plots of the points connected by roads by creating this function q of theta, where an increment delta theta is calculated as 2 pi over n, and then the coordinates x and y are created, and a point or coordinate xy and its reflection about the origin minus x minus y are created, and also a matrix that shows the connection between xy and minus x minus y. since I have n points, actually 2 n points, I'm going to go from index 2 to n over 2. And the reason why I go to n over 2 is because every point that I animate will have a reflection, so I only need to animate n over 2 points. I'll go calculating a new theta to k, which is a theta incremented by a certain number of delta thetas, and that allows me to calculate new values of x and y. And then the value that I originally had here gets stacked with respect to the new value, and then I also keep producing the bars that connect the points. And as I complete this for loop, I end up with a matrix of points, and then I'm going to end up converting these matrices into a system, and that is enough to produce bars moving with points rotating about the origin over the circle of certain radius, the red circle. And what I do here, I can change the value of n, how many points I want, and this has to be an even number. If I try an odd number, I do get some result I never tried before. So let's try with 4 here. I'm going to try 5 and see what we get. The even numbers look better. And I can get up to like 12 or 16. With 16, it gets pretty crowded. But that's this is a generic function that would allow you to plot that many points joined by straight lines. And if we get something like n equal 24, for example, it's going to look pretty crowded. Almost looks like a wheel. These are some examples of animation of points. And the reason I wanted to show them, although this is kind of like simple, is because I'm going to be using the animation of points to illustrate the animation of mechanisms in the next video. And so at this